This is our last topic in inequalities before we move on into systems, which will be coming up next. So we're going to take this idea of compound inequalities one step further and introduce the idea of absolute value inequalities. We've already done absolute value equations, where we would split into two cases because the equation effectively represented a distance away, and it could be either positive or negative in direction. And so since both are the same distance away, there would be a positive version and a negative version. They both count as answers. So that's why we would split into two cases. Remember that? And both of those two cases are the same distance away, and that's what we're talking about with absolute value, is distance away. Okay? And since we have two possible outcomes that are both equally valid, we have two possible answers in an absolute value equation. So let's look at an example just to review. Here's an example. Absolute value of the quantity k minus 10 equals 3. This means that the quantity k minus 10 has a value of 3 or negative 3, because the absolute value, notice this is the absolute value right here, so the absolute value is 3. And because the absolute value is 3, there are two numbers that have an absolute value of 3. Those are 3 and minus 3. And so because there are two possible numbers that have the same absolute value, we split into two cases, the positive and the negative case, and solve them individually. Okay? We did that already. So now consider this. The absolute value of x is less than 2. What does this mean? This means that the distance away from 0 is less than 2. This is talking about what is x. It means whatever distance away from 0 is less than 2. So if we look at something on a number line, here's 0. The distance away from 0 is less than 2. So the distance away, we can go this way 2 or this way 2. And since we're talking about the distance that's being less than, we're talking about this distance right here, and we're talking about this distance right here. Because remember, if I'm at minus 2 right here, I'm going back towards 0, and if I'm at plus 2, I'm going this way. So this would be my graph. And of course, now that we've done compound inequalities, we know how to graph these things that have two boundaries, and so that's what it would look like. They're both open circles because it's less than, it's not equal to, so it's just that and that. If this is confusing you, you don't have to put these little arrows. I just did that to help understand what's going on. What about this one? So this is what happens when it's less than, because it's less than, so it's coming back towards 0 on both ends. What about if something is greater than 2? This means the distance away from 0 that's greater than 2. So what happens if we try to graph this? Okay, so here's 0. Now the distance away is greater than 2. So here's 2 and here's negative 2. Anything in this region right here would be less than 2, right? That's what we graphed above in the blue. So any of that region right there, and let me just zoom in just so that we can be really clear that we're seeing this right. Okay. So notice here, any of this region that I'm shading right here is not going to work because the absolute value there is less than 2, and I'm interested in greater than 2. So all of this region in here is not going to work, right? Because all that is an absolute value of less than 2. So none of this is part of what we want. It's exactly what we plotted here in the blue. So what would this be? The absolute value of x is greater than 2. Well, that means we start at 2 and they're open circles, and we're going greater than. The absolute value has to be out here somewhere, so it's all of this and it's all of this. Because here the absolute value is greater than 2 going in the plus direction, and here it's greater than 2 going in the negative direction. But I don't care if I'm going plus or minus. Both of these are equally valid because it's absolute value, and there are two versions of everything in absolute value. There's a plus version and a negative version. Okay? So let's keep this in mind. This should be really popping out to you of what we're going to be looking at here. Because when we did compound inequalities, This was an and statement, right? Also called a conjunction, by the way. Conjunction. And this was an or statement, or which is called a disjunction. In these words, junction means joining together or coming together. Con means like bringing together, and dis, like disconnect, means breaking apart. So that's why this solution is broken apart into these two disconnected pieces, and these have conjoined or combined together into one little bit. And so that's an and statement and an or statement, conjunction, disjunction. And that's what this looks like when you have less than or greater than. So let's extend this to make a general rule. And here is our method we're going to be doing with this. Okay, here's the method. The method is to translate an absolute value inequality into a compound inequality, since the absolute value means it could equal two things. And a compound inequality is two inequalities smushed together. Make sense? Seems very logical. Okay? So the following holds true for all absolute value inequalities. If it is less than, okay, if it is less than, just like this symbol right here, if it's less than, the solution will converge together, and you will have a conjunction, an and statement. So if this absolute value is less than something, you can write it as a conjunction like this, an and statement, a compound statement like this. And notice that what I have here, okay, notice that what I have here is the stuff in the absolute value is this stuff right here, okay, and then it's less than C, so it's, of course, that means it's greater than negative C and less than positive C. If your absolute value inequality is more than, if it is more than, just like this symbol right here, more than, the solution will diverge apart, diverge, and you will have a disjunction because the solution has diverged, it has not come together, and this is an or statement, okay? And so if you have an absolute value is greater than something, that will translate into, again, this is the same thing I've got in here, and that's exactly what I have right here, and it's less than the negative version, or it's bigger than the positive version. And that's why we had these two situations right here. It was less than the negative version going down this way, and it was greater than the positive version going up that way. That was the or statement. And of course with the and statement, it's bigger than the negative and smaller than the positive. So here, of course, it's bigger than the negative and it's smaller than the positive. Makes sense? Just stare at that for a second. Okay. The same applies, of course, if they're equal to. So less than equal to, greater than equal to, the same two rules apply. Okay? So let's look at some examples. Let's look at some examples. I have some quick examples. I'm going to whip through these, try to keep this video a little bit shorter than the last one. And I'm just being really intentional with this because these are complicated ideas to get your head around the first time. Okay? There's a lot of nuance. So examples for these would I would ask you to solve and graph these. Okay, solve them and graph them just like with any other inequality. And the graphing really doesn't do anything mathematical other than provide you with a visual representation of visualizing what the solution actually means. So what if we had an example n over 4, and this is the absolute value. It's the absolute value of the fraction n over 4 less than or equal to 3. Okay, so looking at our chart here, it's less than, see this? Less than, the equal to doesn't matter. So it's less than, so I'm going to have a conjunction. And so I split this into n over 4, okay, is less than or equal to 3, but it's also greater than or equal to negative 3. All right? So and that's just going off of this little arrangement like this. So whatever it is greater, whatever it's less than the positive version and greater than the negative version. So it is less than the positive version of 3, and it's greater than the negative version of 3. Okay, because this is a conjunction, so it's gonna converge together. The two parts of the solution are going to converge. And so now that we're in this position, we can use the rules about compound inequalities that we know to split these apart. So we just split this apart, and we have our case 1 and our case 2. And so the case 1 would be negative 3, and here we would have this one. Of course, we're multiplying by 4, so we have negative 12. We're not changing the sign. And here we're multiplying by 4, and we're not changing the sign. And so then we can combine this back together, right? We can combine this back together. And so we have n is bigger than or equal to negative 12 and smaller than or equal to positive 12. And so if here is 0, I'm going to use a marker to do this. Here's 0, here's 12, here's negative 12, and of course we're interested in the convergence of these two, so it's bigger than the negative version. So here's the negative version, and it's filled in because it's equal to, so it's bigger than the negative version, so I'm going up that way, and it's less than the positive version. So here's the positive version, and it's less than, and so here I have the solution like that, and these are filled in. Okay, here down here, this is less than, so we know we're going to have a conjunction, so we can write it like this. Then we split apart into case 1 and case 2. So here's case 1 is negative 9 and x plus 5, and here case 2 is x plus 5 less than 9. Okay, so if we're subtracting 5 excuse me, so we're subtracting 5, so we get minus 14. So x is greater than negative 14. And here we're subtracting 5, and so x is less than 4. So here's an example of where we did not get symmetric examples or symmetric answers. These were symmetric about 0, minus 12 plus 12. Here we're not getting symmetric answers. Not symmetric about 0, at least. It's symmetric around 9, right? 9? No. Wait a minute. What's the difference here? 4. So 18 divided by 2 is 9. So negative 5 would be the symmetric point right here. But I'm not having you do that. Okay. So this is going to be a conjunction, and so we bring these back together. We bring these two statements back together right here, and we say that x is of course bigger than negative 14 and less than positive 4. And so if here's negative 14 and then here's positive 4, it's bigger than this, it's bigger than negative 14, it's smaller than positive 4, and so you can see we're starting to get this part here in the middle. These are open circles because it's not indicated that they're equal to. And just like up here, these were equal to, so we fill them in, right? Because it was actually equal to those numbers. And so here's what that looks like. Now let's look at a greater than, which will be a disjunction. So with the disjunction, we set it up as x over 6 is greater than or equal to 5, and which is exactly how it's written, right? It's exactly how it's written. We're just taking the absolute value out. And then we set up the negative version, so x minus 6 is of course less than or equal to negative 5. So this greater than 5 is going to be with the 5, it's going to go up to positive infinity, less than negative 5 is going to go down to negative infinity. That's how we're getting the disjunction there. So now we multiply across and we get 30, and we multiply across and we get negative 30. So it's greater, and this is or. So we have x is greater than 30. So here's 0, here's 30, here's negative 30. It's bigger than the positive version, and it's equal to. So we fill it in, and it's bigger than the positive version, or it's less than the negative version. So we fill it in, it's less than the negative version. Okay? And we have a disjunction. So now let's look at another disjunction. It's greater than, right? Immediately tells us we're going to have a disjunction. So 7x plus 4 I'm just rewriting it exactly like it is without the absolute value, and then I come over here and I set up the negative version of the whole thing. So here I'm subtracting 4, and here I'm subtracting 4. Okay? And so then we're dividing by 7. And here I'm dividing by 7. Does that go in evenly? I don't think it does. 78 divided by 7. No. That's about 11, but it's a little bit different. So we'll just leave this. It doesn't reduce, so 78 sevenths. I didn't think that looked right. Okay. So this is about 11 point something. Okay. Or rather, a negative 11. Okay. So there's that. So we're looking at the 0 here. We're going to have bigger than positive 70. So here's positive 70 way out here. And it's bigger than this, and it's equal to. So there's it's equal to, it's bigger than this. And then here's a negative 11 right here. We'll make it really close. And it's less than or equal to that. So fill it in, and it's all of this way down here. Right? All the way up. Okay? Absolute value of 3 plus r divided by 7. Notice that the absolute value is only around the stuff in the numerator here. And then it's divided by 7, and the whole thing is less than or equal to 5. So this is going to be a conjunction, right? But just as before, we have to isolate the absolute value before we can split it into 2 parts. So we multiply across by 7. We get this. And now we're back to where we were before. Okay, so now we can split. It's still a conjunction. Okay. Okay, so if we subtract 3, and we subtract 3, okay, then we're getting, what are we getting here? We're getting a 0, we're getting a minus 38, and we're getting a positive 32. So it's bigger, so r is smaller than 32. So here's 32, it's filled in. It's smaller than 32, and it's bigger than, it's bigger than negative 38. So here we are filling in, and it's bigger than negative 38. So we're going to have this conjunction right there. Okay? In our last example, same kind of a thing, but this is going to be a disjunction. So we set it up like that. I cross multiply the 2 there. And so, that's still absolute value. So now we can split it apart. So that's without any changes. And then flip it and get the negative. So it's bigger than the positive, smaller than the negative. This is going to diverge. So let's figure it out here. So we're subtracting 2. We're subtracting 2 and then dividing by 3. Get 8/3, and then we're subtracting 2 and then dividing by 3. None of this is changing my signs. Dividing by 3, and so x is bigger than 8/3. Where is my, oh wait, so bigger than 8/3 and smaller than negative 4, and then, which, by the way, 8/3 is what? What number is 8/3? I'll let you figure that out while I'm getting the right pen here. This is a disjunction. I need blue. Okay, did you figure it out? 2 2/3. So here it is. Here it is. These are both filled in. It's bigger than 8/3, and it's less than negative 4.